Okay, the first thing here I wanted to do in your e-learning today was to go over this worksheet that we had from the other day with Thomas Hunt Morgan and Alfred Studevant. So we're just going to go through here real quick and review this. If you need to make corrections on your worksheet and resubmit, do that. Okay, but again, this needs to be submitted by the end of class with the final version. So your first question here, what did Thomas Hunt Morgan discover that seemed to violate Mendel's laws? Now, we have not talked about Mendel yet. Gregor Mendel is the father of genetics, and he had three principles that we will be talking about later on. But according to Mendel, no trait affects the outcome of another trait. That's called the law of independent assortment, or Mendel's law of independent assortment. But through the work of Thomas Hunt Morgan, who came after Mendel, we have discovered that certain genes are linked and passed together, or as one. Okay. Now, the only way this is possible is what question 2 is about. So how did Morgan explain this? Well, according to Morgan, the only way that genes can be linked or passed on together is that sorry, go back here. Oh, I'll keep messing up. Sorry, I forgot to underline. The genes have to be carried on the same chromosome. Okay, so as the chromosome moves, so do the genes. So obviously, if two genes on the same chromosome, they're going to be passed on together. Basically, we can think of chromosomes as nothing more than groups of linked genes. Okay. So in turn, we run into Alfred Studevant, and what he did was he looked at what Morgan had come up with, and then he looked at crossing over, and by looking at the crossing over frequency, and was able to determine their location on specific chromosomes. Again, sorry, I forgot to underline this like I should have, but there you go. So again, he used the frequency of genes crossing over. Okay, and as we mentioned earlier, or in the thing, the more closely they are on the chromosome, the less frequent the crossing over. The farther they are towards or the more frequency of crossing over, the farther apart or they are on a chromosome, or they are located towards the edges. Okay, so that leads us to the gene map. And this is the one I showed you in class today, chromosome 2 of a fruit fly. And this is what one of the maps that Studevant was able to make. Okay, and you can see there are several different traits here. And from that, looking at the frequency, Studevant was able to identify the locations of these different traits and their position on the chromosome and position relative to each other. Okay, so that gets us down to what this is all about. So very simply, it's what I just said there. Okay, what does this gene map show us? This is what this diagram is. It shows the location of several genes on chromosome 2 of a fruit fly. Now, it is not all of the genes that are on there, it's just some of the genes, okay, and where their particular location. There's genes all the way down, okay, from 0 to 107. But this is showing you the location of several of those genes. So how was Studevant again able to gather this information. We answered this already up at the top. But what he did is he did this by comparing the frequencies of the genes crossing over during meiosis. Okay, and by again, if he found that they had a similar frequency of crossing over, then they must be close together. If there was a big difference, then they didn't cross over together and they were farther apart. So therefore they were not linked. Again, genes that are close together are linked. Genes that are on opposite ends or far apart are not necessarily linked. Okay? So if we use this graph here, or this map here, which pairs of characteristics are more likely to cross over, curved wing and a dumpy wing, or a curved wing and a vestigial wing, you simply look at how close the numbers are together. If we look at the curved wing, if I find it on here, is right here at 75.5. The dumpy wing is up there at 13. So if I find the difference here, then that we have a difference here of 62.5. Okay, and again we're talking about the frequency of crossing over, the percentage of crossing over. And then if I look at the curved wing and the vestigial wing, the curved wing again was 75, the vestigial wing is 67, excuse me. That is only a difference of 8.5. So which one is more likely to cross over? Well, the ones more likely to cross over are going to be the ones that have the greatest differences, and that would be the dumpy wing and the curved wing. So the dumpy wing, I don't know why that went up there, my apologies. The dumpy wing and the curved wing are more likely to cross over because they are farther apart on the chromosome. So which ones are least likely to cross over? Now for this particular question, you were not supposed to be just looking at these two choices, but you were supposed to look at the entire thing. So the ones least likely are the ones that are going to have the lowest difference, and if you look real close here, we can do that with eye color right there. So the genes least likely to cross over are the purple eye and light colored eye are least likely because they are genes that are closest together on the chromosome. Okay, so again, the bigger the difference, more likely the crossing over. The closer together, the least likely the crossing over. Okay, if the curved wing were to cross over, the vestigial wing is probably going to go with it. That's why those frequencies are so similar. Okay, that's why the frequencies are so similar. Okay, so let's move on to your second page here, and you're giving 4 different chromosomes. Okay, each of these chromosomes shows the position of gene A, B, C, and D. you could see in each one, especially in A, B, and C, there are differences between A and B, B and C, C and D. And then on chromosome D, C and A have switched positions. So we're simply, again, looking at the distance between chromosomes to determine the likelihood of crossing over. And when gene map, then, on number 8, is the probability of crossing over between A and D the greatest? So again, greatest means distance, so we have to look. We go for the first one, 5 and 12, 17. 17 and 8 is 35. If we go to the second one, 8 and 20, 28, 28 and 5, that's 33. I'm sorry, this top one here was 25, not 35. My apologies, 25. This one is 33. We get to C, we have 8 and 17, 25, 25, 12 is 37. Okay, so you can see here the distance between A and D is getting thing. Now if we go down here to this one, A and D are only 8 apart. So one with the greatest chance of crossing over would happen to be C. Okay, C would have the greatest chance because it has the greatest differences between the two genes, or the greatest distance, I should say, between the two genes. As we keep moving on here, and which gene map is probably of A and D the least, so now we need A and D to be very close together. And actually that happens to occur right down here on D. They're only 8 apart. If you remember, we went 25, 33, 37, and 8. So that is letter D. Okay, and then we move on to question 10. In which map are genes C and D most likely linked? And in order to be linked together, they would have to be very close together. So in this one they're 8, in this one 5, this one 12. C and D all the way to the end is going to be 25. So we take the lowest number, and that has to be on B. Okay. And finally, which genes are least likely to cross over on map D? So we're looking for the two that are closest together, and the two that are closest together is C and B. There is a difference of only 5 spaces on this particular map. Okay, so again, we're just seeing which ones are closest together, which ones are farthest apart. The closer together are, the more likely they are linked. The farther apart they are, the least likely they are linked. Okay, now let's see if you had any understanding on all. We see we have some household cats with orange fur and dark orange stripes. If they're striped, they're tabbies. However, some of them just have black patches, and these are torties. Okay, and it happens to be that the male cats are always, or tabbies are always males, and torties are always females. So, what can we do, and how does this have to do with gene linkage? What we can figure out here, if we look very closely, is the gene or genes for fur coat, I should say, are found on the sex chromosomes. Okay, in particular, they are found, and this is because I understand this a little bit better, I can tell you they are even found on the X chromosome. Okay, females, as we talked about, have 2 X's. Males have an X and the Y. Okay, one of these traits is considered dominant. One of these traits is considered recessive. Okay, and I'm going to go with tortie being the dominant and the tabby being the recessive, and that's why it only shows up in males. Okay, so again, make any corrections that you need to make, resubmit this, and I will get it graded for you. And then you will need to move on to your preview Kahoot, and then watch the video with Hank Green in Crash Course Biology on DNA and replication. Have a good day.